A push server sounds simple. An event happens, and a user gets a notification. At scale, the hard part is not sending one message. It is knowing who should receive it, where their live connection or device token is, how to fan out without melting the system, and how to retry without delivering nonsense duplicates. A clean design separates two planes. The control plane stores users, devices, subscriptions, topics, permissions, and preferences. The delivery plane moves messages. It accepts an event, queues it, expands recipients, routes to connection gateways or external providers, and records delivery state. Mixing those two planes is how small notification systems become fragile. Keeping them separate also lets you scale them differently. Subscription rights are database-heavy, while delivery is queue-heavy and network-heavy. Everything starts with subscription state. A device or browser registers a token or push endpoint. A connected client registers a live socket. The server stores the mapping from user to device, topic to subscriber, and connection ID to gateway node. This registry must tolerate churn, because devices reinstall apps, browsers revoke permissions, and sockets disappear without saying goodbye. Treat every token and connection as a lease, not a permanent fact. For real-time in-app delivery, gateway servers hold long-lived connections. WebSocket is a common choice. The client performs an HTTP upgrade, then messages travel in frames over the open connection. Gateways should stay mostly stateless except for local connection ownership. If a user is connected to Gateway 7, the routing layer needs to know that, but the whole product should not depend on Gateway 7 keeping durable data. On reconnect, the client authenticates again, the gateway refreshes ownership, and missed state can be fetched from the product API. The queue is the shock absorber. Product services publish notification intents quickly, then workers pull at a controlled rate. The queue gives backpressure, retry, scheduling, and a place to survive short outages. Without a queue, a celebrity going live, a price alert, or a sports score can turn one ordinary event into a sudden storm of network calls. Fanout is where scale appears. For a direct message, the recipient list is small. For a topic or broadcast, one logical message can become millions of deliveries. You normally fan out in batches, shard by user or topic, deduplicate device tokens, and enforce rate limits. The best optimization is often to avoid fanout when the message can be fetched lazily after a lightweight signal. For very large audiences, you also need fairness between campaigns, so one broadcast does not starve urgent one-to-one messages. Delivery is at least once in many real systems, so the consumer side must be idempotent. Give each message a stable ID track attempts. Retry transient errors with exponential backoff. Drop or refresh invalid tokens. Send permanently failing messages to a dead letter queue. A duplicate notification is embarrassing. Losing a critical alert is worse. The policy depends on the product. Chat badges, fraud alerts, and marketing blasts should not share the same retry rules. Mobile and browser push usually goes through platform push services. APNs, FCM, and web push exist because phones and browsers cannot keep every app server directly connected forever. Your server sends to the provider wakes the device or service worker, and the app fetches fresh state if needed. That means provider limits, token lifecycle, collapse keys, and privacy all belong in the design. The payload should often be small, enough to wake the app, not enough to become the only source of truth. A production push system is operated through metrics. Track queue lag, fanout rate, gateway connection counts, provider errors, token invalidation, retry age, duplicate suppression, and user opt-out rates. Notifications are user-facing side effects. You need throttles, quiet hours, per-user preferences, and a kill switch before the first incident, not after it. The system should be able to slow down by campaign, topic, tenant, or priority without taking the whole product offline. The interview answer is a pipeline. Store subscription state in the control plane. Accept notification intents through an API. Put them on a queue. Fan out carefully. Route to live gateways or push providers. Retry safely with idempotency. Measure everything. A push server is not a send loop, it is a controlled delivery system.